Hi everybody, this will be your Tuesday video. Still working with unit circles, and we're going to learn today about reference angles. So it's kind of two things we're learning today. Right now we're just going to talk about determining the quadrant in which the angle lies. So hopefully it's an easy lesson. Right here in this little box I have your quadrants. Remember that quadrants go counterclockwise, so 1, 2, 3, 4, those are your quadrants listed. So if I'm giving you and I'm asking you 9/4 pi, and I want to know what quadrant 9/4 pi is, well, we always start right here on the x-axis. This is our initial side, and I want to find out where the terminal side is. Where does that angle end? And where it ends, it will tell me what quadrant it is. So when I see the denominator 4 and it's in radians, that reminds me of how I taught you guys how to learn 45-degree angles. If you recall, I broke this into 45-degree angles. So this is 45 degrees, and then I taught you guys to go 1/4 pi, 2/4, 3/4, 4/4, which equals 1, and that gave you 180 degrees over here. So when I'm figuring out where 9/4 is, I'm going to look at my coordinate plane and I'm going to go, okay, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, which is 2 pi, and then 9/4 takes me right back to here. So what I did is I went all the way around the unit circle. That's 360 or 2 pi. So that's 8/4 pi. 9/4 pi takes me back to right here. So what quadrant is that in? I'm right back in quadrant 1. So the answer to this question is I'm in quadrant 1. So 9/4 pi is all the way back around in quadrant 1. There's my answer. Okay, so I want to look at this. This is example 1. I should put 1 here. So let me go over here to example 2. So my question is, okay, 11/6 pi. Okay, where is that? Well, when I broke something down into 6, when I was teaching you the unit circle and radians, that was your 30-degree angles. And so I was counting by 6. So 30 degrees was 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6 is 1, or that was 1 pi. So if I want to go to 11/6, I go all the way around. That's not quite 12/6, which is 2 pi. So let's look here. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11/6 takes me all the way to quadrant 4. So that's my answer, quadrant 4. 11/6 pi is in quadrant 4. Okay, I wrote a 4. I should make it as a Roman numeral, and that's all it is. There you go. There's your answer. Okay, so my next example, and maybe I should scoot it up a little bit, is, okay, -5/3 pi. Well, wait a minute, we never did anything in thirds. We did things in 6 and 4ths, and of course by halves. Well, let's change it then to something we're familiar with. Let's change it to 6. So I'm going to change the denominator to 6. So I'm going to multiply the bottom by 2. So I'm going to change it to 6. So if I multiply the bottom by 2, I need to multiply the top by 2 also. So I'm going to change this to -10/6 pi. And then notice something. This one's negative. So negative means, I don't know if you remember this several lessons ago, negative means that I started my initial side, always start at your initial side, but now I have to go clockwise. So again, these are 30-degree angles, but we're going to go clockwise. So I'm going to go here, and you can always skip things. Remember, 6/6 is a pi. That's 1 whole pi. So I could go 6/6 here, 6/6, 7/6, 8/6, 9/6, 10/6, but remember this is a -10/6 because I went clockwise. So I'm here in quadrant 1. So right here is a negative 10/6. I'm going to write that this time. Negative 10/6 pi was right here in quadrant 1. So my answer for this one is quadrant 1 because I went clockwise. All right, moving along. This is my question. This was question 3, by the way, so I'll put a number 3 up here. This is my question for number 4. 3.5 and negative 4.8. Where the heck did those numbers come from? They're not degrees because there's not a degree mark. And I'll show you what they are. These are actually still in radians. But it's like this. Okay, well, pi is 3.14. So this is 0 pi here. This is 3.14. So then all we need to do is break this down into radians. So this is 1.57. And then if I add 1.57 to this is 4.71. So what I'm doing is I cut 3.14 in half, 1.57. So I'm going to add 1.57 to this, that's 4.71. And then I'll double 3.14, you know, that's pi. Double that and you get 6.28. So all I'm doing is I'm writing pi as a decimal. So when you see numbers like this, it's writing pi as a decimal. So this is even easier than the others. And once you understand, like, where did that come from? So this is still radians. It's not degrees because there's not a degree mark. So 3.5, what quadrant does that lie in? Okay, well, here's 3.14, here's 4.71, so that lies somewhere in quadrant 3. Just that simple. Remember, you go counterclockwise when it's positive, so this is in quadrant 3. So now a negative 0.48, now remember, you got to think backwards here, so this would be, start at 0. This would be a negative 1.57. I'm going clockwise. This would be a negative 3.14. This would be a negative 4.71. So if I'm looking for negative 4.80, it has to be in here. So this would be quadrant 1. So that's my answer for those two. So the top section I just did is, this is question number 4. What quadrant do these lie in? And there's your answers for those. Okay? If I did it in degrees, I think it'd be even easier than that. So, all right, so, well, let me make one up just real quick. So if I said, okay, what quadrant does 225 degrees lie in? Well, you know this is 180. You know this is 270 if we're looking in degrees. So 225 degrees would have to lie here in quadrant 3. So if you were asked it in that question in degree format, that would be your answer. That's quadrant 3. So now the next part, let me just check my time on my phone to make sure I'm still under 15 minutes, and I am doing good. Okay, so the next little part, I think you can still see it, is a reference angle. Reference angle, I think I mentioned the word, is the distance, and I put these absolute value bars around it because distance is always positive. The distance an angle is, a distance from the angle is from the x-axis. The distance an angle is from the x-axis. So, for example, you're going to be asked to sketch an angle. So I'm going to sketch a 390 degree angle. Well, 390 degrees is bigger than a full circle. So now it's positive, so I'm going to go counterclockwise, and then it's going to ask me, well, what is the reference angle? So first off, I'm going to start here on the initial side, and I'm going to sketch a 390 degree angle. Well, if I go all the way around a circle, so far I've got 360 degrees. How much further do I need to go? All right, well, 390 minus 360, because I've already gone 360, I have 30 more degrees left over. Okay, so I'm going to guess 30 degrees, because you're sketching, so you don't have to be perfect. It's about somewhere right there. So I draw that little arrow so I can show the direction I've gone. I just drew I've sketched a 390 degree angle. That's it. So there's your sketching of a 390 degree angle. They're kind of cute because it looks like a little snail going on in there. So now, what's my reference angle? Well, your reference angle is how far is this terminal side, so here's your terminal side, from the x-axis. What's the distance from here to here? Well, if I had to go further 30 degrees further, then my reference angle is always 30 degrees. 30 degrees. Okay? Your reference angle is never greater than 90. It's the distance from the x-axis, never from the y, only from the x, never from the y. So now I'm going to go back and I'm going to show you from our examples we've already done. We're going to look for the reference angle here. So remember on number 1, we had to find 9/4 pi. So if I was to sketch that graph, so watch me sketch that graph, 9/4 pi, remember we ended up right here, so we went all the way around, there's 8/4 pi, there's 9/4 pi. I just sketched the graph. So if I said, what's the reference angle? So the reference angle for this one, reference angle is, well, what's the distance from here to here? That's 45 degrees. That's the reference angle. Okay, so now let's do this 11/6 pi. Well, if I sketch that graph, starting here at the initial side, it's positive, so I'm going to go counterclockwise. We ended up right here. That was 11/6 pi, because remember that's 12/6 pi all the way around the circle is 12/6, because that's 2 pi. So I'm going to start here at the initial side. I'm going to go all the way around to 11/6 pi. Okay, so there's my sketch of that angle. Now 11/6 pi, remember it's counting by 30s. What is the distance from here to my x-axis? Well, the distance from here to here, well, let's see. All the way around here, that's 330 degrees. And if you're not sure about that, you can always multiply that by 180 over pi to get rid of it. But I think if you remember, this is 30 degree increments. The distance from here to here, so my reference angle is 30 degrees. The distance from here to the x-axis, that's 30 degrees. Okay? Or you can do this. It's 2 pi, which is 12/6 pi minus 11/6 pi, gives you 1/6 pi, which is 30 degrees. Why make it that hard? Okay, 2 more. Okay, this one over here, negative 10/6 pi. All right, so I got to go backwards. I kept that one marked. So if I go around this way, there's my sketch of that graph. I had to go clockwise. What's the distance from here to here? Well, that's 2/6 left over, which is 60 degrees. So my reference angle is 60 degrees. Reference angle is 60 degrees. How am I doing on time? Gotta do the last one, and there is no last one. That was it. That's all my reference angles, because those don't count. Okay, hope you understand. If you don't, please meet me on Meet. Okay, peace out.